Hello everyone! In this section we'll be going over how to use the programmable gain amplifier and differential voltage settings on the external analog to digital converter. So the programmable gain amplifier is a small amplifier that's built into our external ADC. It allows us to modify both the voltage range as well as the resolution of the device. That's because as the maximum voltage decreases, the resolution is going to increase because the same amount of bits are going to be used to represent the range between 0 volts and the maximum volts. That means each bit in that 15 bits is going to be used to measure a smaller range in voltage. The maximum gain on the device is 16 times, which means that we're going to get a much higher resolution than the minimum gain of 2/3 that we were using in the previous section. A gain of 16 times means that the maximum voltage is going to be around 0.256 volts, meaning that 15 bits are going to be used to represent the voltage range between 0 volts and 0.256. The differential voltage is a way to measure the voltage difference between two analog pins on the external analog to digital converter. So there are 4 analog pins here, and we're going to be using the differential voltage between pins A0 and A1 in this lab. When you use the differential voltage setting, what it does is it measures the voltage at each of those pins and then subtracts the voltage, and that's what it outputs to the Arduino. Using a combination of a really high gain as well as a differential voltage measurement can mean that you can measure very precise differences between two small voltages. So in our case, we're going to be measuring the very small difference between two voltage divider circuits that should theoretically be identical, but due to the inherent differences between some of the resistors, we're going to see a small difference in voltage in the external analog to digital converter. We have here one 10k ohm, another 10k ohm, a third 10k ohm, and then a 1k ohm resistor. These are all in series and go from 5 volts down to ground. We built the same circuit again immediately to the right of it, the exact same circuit, and in between the third 10k ohm and the 1k ohm resistor, we put jumpers to the analog pins on the Arduino, as well as jumpers to the analog pins on the external ADC. We're going to be measuring the analog voltage at both the Arduino at both of the pins, as well as the differential voltage on the external analog to digital converter. Otherwise, the circuit is the exact same as the one from the previous section. We're just using 2 analog pins instead of 1 analog pin on both the Arduino and external ADC, and we're using a voltage divider circuit instead of the temperature sensor. Alright, now that we've gone over a bit about how the gain works, as well as what differential voltage is, and looked at our hardware, let us go to the code, and we will actually read in those values and then see what they look like. Let's get to it. Now that we've gone over our design, in order to read in the 2 voltages from our voltage divider circuits through both the internal ADC of the Arduino as well as the external ADC we're using today, we need to write some code to actually view those values on this serial monitor so we can analyze them. To begin our code, we're going to include the 2 libraries like we did before, the wire and Adafruit ADS1015 libraries. After that, we instantiate an object of Adafruit ADS1115, again, just like before. Inside of setup, we begin serial communications with our serial monitor at a baud rate of 9600. After that, we run ads.setGain, and inside of there we put gain 16. This means that the gain of the programmable gain amplifier inside of the external ADC is going to be set to 16 times. This gain amplification means that the maximum voltage will be 0.256 volts. After that, we run ads.begin, which begins our communication with the external ADC, and it remembers that we set the gain to be gain 16. Inside of loop, we instantiate 3 doubles, external, internal, and internal 2. External is going to be equal to the result of ads.readADC differential 01. This returns the differential voltage between pins A0 and A1 on the external ADC. After that, we need to read in the 2 analog values on the Arduino with analog read. So internal is going to be equal to the analog read of 0, and internal 2 is the analog read of 1. After that, we need to convert these values into actual voltages. So we're going to run external is equal to external times 0.0078125. This number comes by doing 0.256, the maximum voltage, divided by 2 to the 15th minus 1, so its representation in bits, and then multiplying it by 1000 because we want millivolts. As the difference is going to be so small, it's much easier to look at it in millivolts. So for internal, we multiply it by 4.888. This constant comes by doing 5.0 divided by 1023 multiplied by 1000, again for millivolts. We do the same thing for internal too. After that, we take internal and from it subtract internal 2. This gets the differential voltage between those pins. After that, we run serial.print, and we print the high resolution differential and the low resolution differential voltages. From that, we have finished our code, so we can upload it to the Arduino. Once it finishes uploading, we will open up the serial monitor. Alright, there we go. And we should see some values spit out into the screen. As you can see, we have a difference of 0.84 millivolts according to the external analog to digital converter, and the internal one says it's 0, but then randomly jumps to 4-ish, or 9 as you can see up here. And the sign seems to switch back and forth between negative and positive. This is because the difference we're looking for is extremely small, so it is very, very weak to noise. It'll vary very greatly depending on any fluctuation on the input signal. So if the 5 volt input to our voltage divider circuit, say, decreases by even 1 millivolt or increases by a handful of millivolts, the measurement is going to change pretty dramatically because the difference we're looking for is so small. Thus, if there are any noise fluctuations, the low resolution value is going to change quite a bit, whereas the high resolution of the external ADC has built-in filtering systems, so these small fluctuations aren't going to be really noticeable. As you can see, it's only fluctuating by about 0.01 millivolts, which is a very small amount. Whereas this one, on the low resolution side, either spits out nothing or garbage, so you can't use it at all. It's completely useless information. Whereas the high resolution value gives you something that you could read if you were actually curious about the voltage differential between two very small, very similar inputs. Thus, we have demonstrated another use for the external ADC, and we have finished our lab. As always, we hope that you enjoyed this video and that you like, comment, and subscribe. In particular, we hope you comment some ideas for future videos or improvements we could make for our current format. Thank you, and see you next time.